Good morning, class. We're going to keep going with our word problems, and this next section, 7.8, is going to look at something called work problems. So the basic scenario that's going to be happening is if someone can complete a job in a certain amount of time, and another person can complete the job in another amount of time, then how long would it take if they worked together? And similar to our percentage problems and our mixture problems, the investment problems, those like that, we're going to set up a chart to help us get our answer for this. So let's think back to our previous formulas that we've used. Basically, they've been in some kind of format similar to, some total amount or quantity times some kind of rate. Depending on what the problem is, this rate might be a percentage, like an interest rate, or a sales tax, or the percent that something's on sale. Or think to like the mixture problems. We did some with like products, so it might be the price per unit. And then when we multiply those together, we get our amounts, or it might be the cost, or it might be whatever that problem it was in context. Okay? So with work, we are going to use a similar type of formula. We're going to have some type of work rate, and we're going to explain what that is in a second, times the time equals the amount of work completed. Okay, so let's kind of explain what do each of these variables, what do they actually represent? So our work rate is going to be the amount of work that can be completed in 1 unit of time. So if one problem might be talking about days, another one might be talking about hours. So however much work can be completed in 1 hour or 1 day or 1 week or 1 month, whatever that unit of time is. Now, one thing to make sure of, make sure that the unit of this time matches the unit of that time, okay? So these must match. So you might have to convert, minutes to days or whatever you need to do to make sure those units match. Okay? So once we multiply those together, that's going to say how much work was actually completed. So then, when we're in our table, the formula that we're going to use from the table, and this will make sense as soon as you see it in the table below, for example 1, it will basically be the work done by A, whether it's a person or a machine or whatever it is, plus the work done by B is going to equal 1. And you might be wondering where this 1 comes from. Well, let me explain it in context of example 1. It says, Josh can paint a house in 4 days. His father can paint a house in 2 days. How long will it take them to paint the house together? So, in this case, once we have our table set up and we're trying to write our equation, it's going to be the amount of work that Josh does plus the amount of work that his dad does equals 1. And that 1 should hopefully make sense now because when they work together, now they've completed and painted 1 house. Okay? So this 1 symbolizes 1 job completed. Okay, so let's go ahead and set up a table now that we read this problem. We have Josh and we have his dad. We have our work rate times our time equals the work completed. And I'm actually going to use variables for this from after this problem. So our work rate can be the R times T equals the amount of work, which is W. Okay, so let's finish that off. So Josh can paint a house in 4 days. So the rate that he's painting the house is 1/4. basically he's painting 1/4 of the house every day. So day 1, he's completed 1/4 of the work. Day 2, he completed another 1/4 of the work. Day 3, another 1/4. Day 4, another 1/4. Altogether, all 4 days, he completed painting an entire house. Okay, so we don't know, when they worked together, we don't know how long it took them. So that's going to be our X because they were painting the same amount of time for some amount of time that we don't know. But now when we multiply this across, we're going to get X over 4. Okay, now the dad can paint the house in 2 days. So that means after day 1, half of the house is painted. And then day 2, another half of the house is painted. So that's his work rate. Again, they're working for the same amount of time when they're this question says, how long will it take them to paint the house together? So that's why these times match here. So when we multiply across, we get X over 2. Now, all together, when they are painting together and working together, they get one house painted. So we have our equation, X over 4 plus X over 2 equals 1. Now we can see we have a rational expression. So easiest thing, let's multiply through by our LCD. So we're going to end up with X plus 2X equals 4. Let me go up here with this. 3X equals 4, or X equals 4/3. Okay, well, let's make sure we understand what that means. Our unit is going to be days because that's what the unit of time was in the problem. So we could say, therefore, it takes 1 1/3 days for them to paint a house together. And you always want to make sure that your answer makes sense. So if it's taking Josh 4 days and it's taking his dad 2 days, you're definitely expecting it to take less time than 2 days, right? Because if the dad can paint it by himself in 2 days, it has to be lower than that number. So this answer does make sense in the context and the information that we were given. Okay, let's take a look at the next one. One printer can finish a job in 8 hours. The same job would take a second printer 12 hours. How long would it take both printers together? Okay, so we're going to set up our table. We have the rate times time equals the amount of work done. I'm just going to call these printer A and printer B. You could have called them printer 1 and 2. It doesn't really matter. Okay, so here's our table. And I want you to think about, what are we actually solving for? Where is our variable going to be going here? Okay, so if we take a look here, we have printer A can finish a job in 8 hours. Think about what our rate is. Go ahead and fill that in. Printer B can do it in 12 hours. What's their rate going to be? Hopefully you got 1/8 for printer A and 1/12 for printer B. We don't know how long it's taking them to print together, so once again, this is very similar to example 1. We're going to have X for both of them. Very similar to example 1. I want you guys to go ahead and set up your equation, and then go ahead and solve for X. Okay, hopefully you're getting x is 4 4/5. So therefore, it would take 4 4/5. Our unit here is hours. To print if working together. Okay, so far both of these examples have been really similar to each other, but you're not always going to just be solving for time. Let's take a look at a different example where you're kind of giving different information and you're asked to find something else. So flip it to the back, and we can see it says Jeremy can shovel snow off his driveway in 40 minutes. He shovels for 20 minutes and then is joined by Megan. If they shovel the remaining snow in 10 minutes, how long would it have taken Megan to shovel the driveway alone? So here's our question. So you can see we don't know Megan's rate. Okay, so let's take a look at this table. We have Jeremy, we have Megan, okay, we have the rate times the time that they work together equals the amount of work completed. Okay, so Jeremy can shovel the snow by himself in 40 minutes. So that means every minute he's getting 1/40th of the job done. He shovels for 20 minutes and then is joined by Megan, and then they get the remaining snow shoveled in 10 minutes. So think about how long was Jeremy shoveling for? 20 minutes by himself, 10 minutes with Megan. So 30 minutes. And we're going to keep that in units a minute so that the units match up for both of them. And then Megan, we don't know her rate. So we're going to say 1/x. We know that she was shoveling for 10 minutes. I'm sorry, yes, for 10 minutes. And now we can go and we can multiply across. So we get 30/40. We can go ahead and reduce that to 3/4. And then we get 10/x. But together, they completed one job. So that's always staying consistent. Okay, so let's look at our equation. We have 3/4 plus 10/x equals 1. We can multiply everything by 4x. We have a rational equation. So times 4x times 4x times 4x. We're left with a 3x plus 40 equals 4x. So this is a quick solve. We're going to get x equals 40. So if Megan had been working by herself, she could have gotten the driveway also shoveled by herself in 40 minutes. So it's actually the same rate as what Jeremy was working at. So Megan can shovel driveway by herself in 40 minutes. Okay, I'm going to have you guys practice with some now. The assignment will be on the board, and you can work in pairs together, and as you have questions, feel free to ask Mr. Emilian. And you do have your quiz is going to be on Friday, so we will definitely take a look at the problems that we've done together so far tomorrow and review some. And feel free to also email me with any questions. I'll also be here later in the day, so feel free to stop by as well. Have a great day, guys. Bye-bye.